Hello coders, welcome to episode 204 of the How to Code Well podcast. This is live. It is Saturday the 12th of October and it is 2004. 2004? No, it's 204. That's the episode. It's 2024. There we go. I haven't had coffee today, so bear with me. We are going to be talking about databases today. Now, this may seem like a bit of a boring topic. What is a database? But actually, as a programmer, one needs to understand what a database is, what it's used for, the limitations of the database that you choose, and there is a whole plethora of database choices, the infrastructure in which the database resides on, all sorts of manner of complications and stuff like that. It's actually a massive minefield. So, what I would like to do is take it one step at a time, and we are going to go from the ground level upwards, okay? And before we do this, in the previous podcasts, I did a thing called a changelog, where I would talk about the various different developments of howtocodewell.net. One massive development is that there hasn't really been much content, much change to How to Code Well in the last good few months. But I'm trying desperately to change that, and you'll be seeing more content, more podcast episodes, more tutorials coming through. What I've actually been doing is building the howtocodewell.net website with my courses on there. Now, we'll talk about that more around the end of the show because there's been some changes to the courses that are available. But that's what I've been doing. So please don't think that I've just dropped howtocodewell.net and the podcast, because I haven't. However, what I will say is the format of the podcast and the format of the live streams and the tutorials will certainly change as things go forward, and I'm just trialing things out at the minute, seeing what works, seeing what doesn't work. So please do bear with me if you see a lot of changes. One change I will mention excuse me, is that we have on the live streams now memberships. So if you want to talk in the live chat, then it is a members only live chat for the podcast. Now, the eagle eyes of you may have thought, well, hang on, this is 204, but actually you've only got 200 on the old Spotify's, and we pushed out a 201 the other day. So what on earth is going on with the numbering? Well, excuse me. Well, what I'm going to try and do is schedule these up. So the live show, which I'm doing now, is going to be available for the members only after this has been published. And then once we get to the point of publishing it, I will publish it to everybody. But also in the meantime, I'm going to be pulling down the audio and making it sound much better than it is, because there's many ums and ers, coughs, and you'll probably hear the dogs bark in the background. That's the nature of being live. So we'll tidy that up, and that will then push out to Spotify, as it always has been. But that's the plan. That is the plan. Also, I do live streams. I did one on, what day was it? Thursday, I believe it was, Thursday evening, where we were looking at PHP bad practices. And that was fun. Now, I can't say that this is going to be a regular thing. I have yet to work out my schedule. So please do bear with me. Best place to find out where things are, when things are happening, is to check out Twitter as well as Instagram, because I publish updates to the schedule there. Anyway. Right, let me just grab a drink and then we will crack on with today's show. Right, so what is a database? So I actually have, I've got a huge set of notes here that we're going to go through. And what I would like to do is put this on the podcast site on howtocodewell.net/podcast. And we're going to talk about this, but obviously, knowing me, I'm going to go off onto tangents and side roads and talk about various different stories that I've had in my career regarding this topic. And actually, we'll do that. We'll start by going down a rabbit hole, and I'll discuss what databases I've actually used in my 20-odd year career. I think it's now spanning to about 22, 23 years now. So we started off with Microsoft Access, and I built projects around Visual Basic 6, I think it was, and I was integrating with Microsoft Access. That is a database. I've obviously done a lot of work with MySQL over the years. MariaDB as well is another variant of that. I've also worked on MS SQL, which is the Microsoft SQL, and we'll talk about what SQL means because you'll see that crop up quite a few times. I've built things using SQLite, which is another variant. And again, we'll talk about that. I've also worked on things that are more enterprisey. So Oracle, I did in university. I studied Oracle. That was Oracle databases. And then there's been a whole bunch of sort of NoSQL, and we'll talk about what NoSQL means in a minute. I'm throwing a load of terms around at the minute. We'll dig into those. So NoSQL, I've been doing things with MongoDB. I've done stuff in DynamoDB. I've done things in Redis. I've done things on CouchDB. These are all various different databases, and the list goes on and on and on. Excuse me, the list goes on and on and on. So databases is something that as a web developer, as a programmer, you really can't get away from. And some developers will touch it more than others. Some developers will actually become database administrators, and we'll talk about those too, what that means. And some are more geared towards data mining and other things like that. Anyway, and some work on humongous data sets, okay, for the government. So it depends on which level you want to be on. I mean, if you're a WordPress developer, for example, you're going to be using a database, but you're going to be using it through the front end, say, of WordPress. Or if you really wanted to get into the nuts and bolts of stuff, you can tackle the database through the command line, or you could use another type of interface, such as phpMyAdmin, or I think it's Adminer, to actually take a look at the data and manipulate the data in the database without using a front end like, well, it is itself a front end, but without you tackling the stuff in a content management system, you could actually manipulate the data more directly using that stuff. Okay, I have thrown around a humongous amount of terms and various different things. Let's start digging in. You have to excuse me. I'm getting over a very annoying cold, so please do bear with. And I'll try my hardest when I edit this to remove as many coughs and splutterings as I possibly can. Okay, so we're going to take it right the way back to the roots, and we'll actually discuss what is data. So not even what is a database. What is data? What is that? In terms of what we do, what is data? So going through my notes here, data is a collection of facts or statistics Computer data is information that has been translated into a format that can be stored, transferred, manipulated, and consumed by computer processes. And I've got some examples here. An example of data could be, say, a person's age, a person's name, a weight, or eye color. These are factual information about a person. So data represents a collection of facts or statistics, and computer data is information that has been translated into a format that can be stored, transferred, manipulated, and consumed by computer processes. That is essentially what data is. At the most rudimental level, computer data is made up of a sequence of ones and zeros, which is known as binary data. Now, I'm going to do an explainer video like this on binary data at some point, but not today. Just know that from the very lower levels of a computer process, it's going to see the data that you input, however you input it, as zeros and ones, as binary. Okay, so when a computer is processing the data, their values will get categorized into different data types. For example, the person's age might be an integer value, their name and eye color could be a string, and their weight could be a floating point. Say if it was pounds and stones or something like that. So from the binary data level, and we won't talk too much about binary data because I don't want to overly go down many rabbit holes. I just want to focus really on databases and data. But from a binary level, you have the ones and zeros, and then you've got several layers above that the computer then interprets that binary into various different things, and out pops a type of data, be it an integer value or a string or what have you. That is what we then use as a programmer to say, oh, this is an integer value, this is a whole number, versus this is a string, or this is a floating point, you know? Okay, so that is what data is. So what is a database? What is the base of the data? A database is used to organize structured data, allowing for the management and manipulation of data. Now, you may think, well, that's quite obvious, Pete. You know, a database is used to organize the data, right? Sure, because it holds the data. It's the data store. And then, obviously, it gives us tools to manage it. Ugh. But the key word there is structured data. So a database is used to organize structured data, and we're going to be poking that hornet's nest of what that structured means in a minute, allowing the management and manipulation of data. Normally, a database holds the data in a series of tables, rows, and columns. So, okay, let's go back to the person example. So the person example, we could have a table called person, and in that table, we could have columns or fields that represent something to do with that person. I.e., for example, we could have a column of age. We could have a column of eye color. We could have a column of weight, and so on and so forth. When we pull back a row, we're pulling back the columns within that table, okay? So let me just say that all again. A database is used to organize structured data, allowing for the management and the manipulation of data. Normally, a database holds the data in a series of tables, rows, and columns. These can be indexed, so where am I? These can be indexed so that the relevant data can be queried efficiently. So we could index some of the data. If we know that some data is more retrieved than others, right, based on various different queries, and we'll talk about those in a minute, right, then we could index these things. So for example, if we know that a person in the persons table, if we know that that person is unique, right, so that is a unique person, we give that person a number, which is called a primary key, perhaps. That is a unique primary key that is related to that specific person. And that unique identifier cannot be used again because it is unique. Therefore, we should be indexing that column, the ID, the identifier. It is a primary key and it is also unique, right? Therefore, we can index it. Which means that the queries will be returning better when we're saying find the person by the ID of 10, regardless, instead of find the person that has the name of John and the eye color of blue, right? That's probably actually going to return you several people rather than one person that has the unique ID of 10. Okay, so when a database query is made, records containing the data are returned. A database record is a collection of data which is organized into a group of fields. I think I've skipped a bit here. So a database table has a number of fields which correspond with corresponding values, yes. As an example, a person's name, age, weight, and eye color could be a series of fields held within a database table called person, which is pretty much what I've just sort of rabbited on about. So when a database query is made, records containing the data are returned. A database record is a collection of data which is organized into a group of fields. Okay. So a query could be made to return all the names and weights of people that have the eye color of green, for example, which means that you're going to exclude anybody that doesn't have the eye color of green, and you're just going to return the records of the people that do, right? And you're going to limit that query to return only the names and the weights of the people who have the eye color of green, all right? So you're not worried about the age or anything like that, which means that you can create these queries in a very flexible manner, yeah? Okay, so one of the biggest questions that I have seen on the internet, and also one question that I have asked myself a lot and got very confused over the answer with when I was starting out was, is Excel a database? Is an Excel spreadsheet a database? So even though Excel can store data, it is not a database. Excel is a spreadsheet which stores data in a cell or cells, right? So you have individual cells that you can put data in, all right? This data can be formatted, edited, and controlled within that cell. A database, however, has records that contain data that come from external tables. That is the key, that is the clincher. So a database will have multiple tables, and a spreadsheet will just have a spreadsheet with various cells on that sheet. This means that Excel is technically a static document, while a traditional database is relational. Now, this is where the rabbit hole gets a bit deeper, doesn't it? So this means that Excel is a static document, while a traditional database is rational. Bear with me a second. I just want to check something on the stream. I just want to give me a minute. I'm just going to go back into the BRB screen. Give me a mo. Apologies for that. I sorry about that. I should have taken a drink whilst I had that break. Okay, so we've explained what data is, okay, and we've explained what a database kind of is, and we've explained that Excel isn't a database. But now we've hit this thing where I've said this means that Excel is a static document whilst a traditional database is relational. What on earth does that mean? A traditional database? So that means that there's databases that aren't traditional? And why did I say relational? What does that mean? Okay, so before we get to the relational stuff and the non-traditional databases, let's first talk about something that I mentioned earlier on, and that is a database management system. What is that? So a database management system, or a DBMS, is an interface between the database and the end user. Okay, a DBMS allows the end user to perform operations and queries against the database. An example of this would be MySQL, Postgres, and I didn't add that to the list. I've used Postgres before. Microsoft Access, and an Oracle database. So these are DBMSs. All right, these are management systems that allow you to manage the data as well as the database. You've got to make that distinction. There's two separate things there. The database itself has configuration. The data has configuration. The database will need to have various different configurations to allow access to users and to permissions and grants and all of that jazz, locking people out of tables, or only allowing certain people, read access, write access, that kind of stuff. Also, the database management system will allow the use of various monitoring tools, right? So you could use that to monitor the database, keep integrity of the data. Database management systems are essentially the front door to the database. It's the connection, if you will, between your app and the data. All right, so a database management system, or a DBMS, is an interface between the database and the end user. A DBMS allows the user to perform operations and queries against the database. This could include data insertions, data updates, data removal, and database schema changes, as well as data querying and formatting. Woo! Database schema, that's another one I've thrown in the mix. We will be talking about database schemas at some point, but right now, don't worry too much about a database schema, what that means. We're focusing on databases at the minute. Okay, a DBMS also maintains the security of the database by handling users and permissions. This is what I was rabbiting on about earlier, about the various grants and the permissions and the read access and the write access and that kind of stuff. Okay, so now now we've discussed what a DBMS is. We can now talk about what a relational database is. Remember up here I said, when we were talking about Excel, I said this means that Excel is a static document, whilst a traditional database is relational, and I just kind of left it there like some weird cliffhanger. So we're now going to talk about what a relational database is. The way I've structured this, by the way, is I've tried to talk about one thing whilst not getting too in the weeds, and sort of like laying out the foundations before I start digging in any deeper. So now we know what a DBMS is, we can now talk about what a relational database is, because there are non-relational databases and they have their own DBMSs. Okay, so a relational database organizes data in a predefined structure and a series of relationships that connect data together. The database will have multiple tables and will use keys to connect related data together. This reduces data redundancy and helps with data management. Also data efficiency, I should say. Excuse me. Okay, so let's just pull that apart for a minute. So the database will have multiple tables, sure, yes, okay, and we'll use keys. Now, I mentioned this before, primary key, for example, when we were talking about the person table, to connect related data together. So related data could be data in different tables, for instance. So we're saying this table can be joined with this table based on these keys. Actually, that is called a foreign key. Okay. All right. So, as an example, our database may also contain a table called medical notes. Each record in this table will be connected to a record in the person table via a key. A query could be made to return the latest medical note that was made against a person with a certain name. Okay. So, imagine, if you will, you've got two tables in your database. One is person, and the other one is medical notes. So, you'll have various different notes per person. Okay, so a medical note is connected by a person. You may have, say, an ID in the person's table, and you may have the corresponding ID connected to that to various different notes. So a person may have 20 medical notes, or 10 medical notes, or even one medical note, but each of those medical notes will have a ID that corresponds to the ID of the person. All right. So when you're connecting the data together, you're saying, find me the person first. Okay. So this person has the ID of 25. Brilliant. Okay. Now find me all the medical notes that are related to the person that has the ID of 25, knowing that that is a primary key and it's unique, which means that no other person will be having that ID in the medical notes. So I am confident to say that all the medical notes that get returned with the person ID of 25 relate to that person. There we go. We've made a connection. We have made a connection between the tables. As the medical notes and the person details are separate groupings of data, they are stored in separate tables, different tables. The medical notes table would have a field that identifies the connected person. This field would be typically an incremental integer, which corresponds to a unique identifier in the person table. The connected field will be related via a key, which allows for efficient storing and querying against the fields in both tables. So, for example, you could say, find me all the medical notes where that person has the ID of that person. You could do that. And it will find the connected fields that relate via the key of that person, the person ID being the key there. Okay, so I used a term somewhere along the line of structured data. And I've also used the term SQL a lot when I was talking about MySQL and MS SQL and Postgres SQL, right? So what is SQL? Well, SQL means structured query language. A relational database management system, RDMS, relational database management system, will use a structured query language, SQL, to manage the data. SQL comes in different flavors depending on the type of database management system used. MySQL is an open source RDMS, whereas MS SQL is Microsoft's version of an RDMS. Okay, so there are the structured query language is used for a relational database. So if you are using a database, MySQL, MariaDB, MS SQL, Postgres, you know that you're using a relational database because you are using structured query languages. And this is the whole point around relational databases, is the structure. You are giving structure to the data. You are defining the data and how the data relates to one another. Okay, so database engineers and administrators can use SQL to integrate with the data held in the database. Typically, this is done in the form of queries or stored procedures. The queries performed by SQL are usually the following. So an update. It is existing data is updated. Insert. New data is inserted. Delete. Existing data is removed. Or a select, where records are returned based on the supplied query. SQL also allows for the management of data definitions, the data schema, and access control. Bear with me whilst I have another sip of my drink. So apologies before. This is actually the first live stream with the members only chat on. And for some silly reason, when I was configuring the podcast, I set it to only viewable by the members. What I need to do after this is turn this off, or to unpublish this so it's only viewable by the members when this is finished. Again, as I said at the start of this show that probably nobody has actually watched yet, I'm still finding my feet on this stuff, so you just have to bear with me. There's going to be mistakes, I'm sure, as we go through this, the new formats of what How to Code Well looks like. Okay, so we've talked about relational databases. We've talked about structured query languages. Heck, we've even talked about what data is and what a database is, okay? What we haven't talked about is what non-relational databases are. What is NoSQL? NoSQL, what is that? This used to be a massive hype train. I'm going to age myself if I put down a date on this. But I remember playing with MongoDB and getting so confused and just couldn't work out what the point of it all was. Way back when I was, I think it was in my first job, about God knows how many years ago. I'm not even going to attempt to say how long ago that was. Let's just say it's well over a decade and a bit. Okay, so yeah, so MongoDB, and then when I was working for another company, we worked heavily on DynamoDB, which is the AWS variant of, it's very similar to MongoDB. And we used that in anger and in production, and it was brilliant and it was fantastic. And from doing that, I was able to see the benefits of what NoSQL is. And I think that every person who plays with both SQL and NoSQL, they go through this sort of period of, what on earth am I doing? This kind of stage of just being very unsure as to you almost have to relearn what SQL is, what the whole point of it is. And then once you start breaking those conventions, you start realizing actually this NoSQL malarkey can actually be used for good and very helpful in certain situations, but it's about pinning down and finding what those situations are. Before I go any further, let's talk about what NoSQL is. So a non-relational database is sometimes referred to as NoSQL. This is because the data is not structured and does not have any defined relationships. Examples of NoSQL include MongoDB, Amazon DynamoDB, Redis, and Couchbase. So there's various different types of NoSQL, like there is various different types of SQL, right? So with NoSQL, you could have, say, key value pairs, you could have cache, you could have documents, and all sorts of various different crazy types of NoSQL. We won't go into those specifics today, but just know that there are a few different types of NoSQL databases such as value, document, and even graph, right? Excuse me. As the data is housed in a single data structure, there are some advantages over traditional relational databases, such as rapid scalability, data flexibility, and high availability. Okay, so whoa. What did I mean there by saying as the data is housed in a single data structure? Well, when we're playing around with SQL, we have multiple data structures, right? Because we have multiple tables, and each table has its own structure, its own defined set of rules. There must be this field, and it must not be null, right? Or this field must be an integer, or this field must be a date time. Or we could even have rules that say every time a new record has been inserted into this database table, we automatically update the created date field. Or likewise, if a record was to be updated, we automatically update the updated by field. That kind of stuff, those kind of rigid rules. And we're saying that this person can only have this set of medical notes, or these medical notes can only be related to this person, right? Really rigid, kind of hard and fast rules, which you need for those kind of examples. You certainly don't want to be playing around with NoSQL when it comes to people's medical notes. You certainly don't want to be playing around with NoSQL when it comes to user access and logins. You want rigidity. You want the ability to actually enforce these boundaries of the data. When it comes to NoSQL, all of that goes out the window, which is why when I started learning how to do this, it was like, hang on a minute, this goes against everything I know. This is so weird. But if you think about it, there are various different things that NoSQL offers that relational databases don't. So, for example, real-time tracking. Okay, so let's say, for example, I'll use an example. Deliveroo or Just Eat or any kind of delivery service like that, they will tell you. And I don't know if they use non-relational databases for sure. I certainly know people who work in those companies, but I'm not asked them this. But an example I could possibly give, I'm speculating a little bit here, where they could use NoSQL is around the delivery section. So when when you've made an order and you're looking at the little person on the bike on your app, on the mobile app, right? And it's updating, and you refresh and it updates, and you refresh and it updates, and it gets a little bit closer to the front door. Those kind of GPS markers don't need to be, in my opinion, stored in any kind of relational database. There's no point there, because it's a set and forget. You set, forget, and remove. Like, there's no point in keeping that data around, right? It is temporary data. It's only needed for when the user who has placed that order to actually know where in relation the delivery person is to the front door, right? Once that order has been placed and then has been accepted, that data is pointless. There's no point in capturing the points of the GPS, storing that anywhere. That becomes redundant data that gets removed. Also, we could be playing around with, say, data that connects perhaps related products together, or recommendations that are related to a single person but always gets refreshed based on the latest purchases. And then once a purchase has been placed, maybe we can store the data in a relational database, the data that has been offered to that person, so we can then see what was actually decided if someone actually clicked the add to cart, that kind of stuff, when we're upselling. But during the process of upselling, during the process of being in that journey, there is no need, in my opinion, to have that as relational data, because it's meaningless until the the point of, I have selected this as an additional item in my cart. Same goes for reviews, right? If we've got a review, one thing NoSQL is good for is that if the data doesn't exist, you're not going to break the system. So if Deliveroo suddenly dropped all of its reviews, Deliveroo is not going to break. However, if the database, the relational database breaks, then you're in a world of pain. So what a lot of people do is they look at the data that they're using and they're going, well, actually, this isn't necessarily business critical data. And so we're going to farm it off to NoSQL. Now, that doesn't mean that the data has any less importance or significance over the relational stuff. It just means that it's sort of, dare I say, secondary to the user journey, right? Okay, so this Amazon product that I'm reading here, or that I'm looking at, has 1,000 reviews, and yet I can only see the first 20 of them. Is that a problem? I'm not going to go through 1,000 reviews, am I? Just so yeah. And also NoSQL, as I've kind of alluded to, can be used as an interim, right? So again, we're going back to that Deliveroo example of the person going from A to B on their push bike to get to the front door. That is interim information. Also, the interim information of recommending a user a product whilst they're going through the checkout journey. And then when they click on the button to add that to the cart, that information is crucial to know what that product was and to know when they added it to the cart. But the rest of the products perhaps aren't as relevant, right? So yeah, it is a question that one has to ask when they come to deciding, how is this data going to be stored? What is the database management system that I need to use to manipulate this data? And you got to ask yourself some really hard questions. Is this data relational? If it is, then definitely put it in SQL. If it's not, or if it's fluid, if it's flexible, if it warrants the need to use NoSQL, then explore it. But be aware that it is very different. Querying in NoSQL is very different. Another database that I've used that I haven't mentioned here is SQLite. I suppose we should talk about that, because SQLite, being another structured query language, is fantastic because it's in a single file, right, that you can use, and you can put that on a mobile phone. And so when you've got a phone app, that's what they call them, the apps. When you've got an app and you're storing data, sometimes that goes to SQLite, and then when it's phoning home, to a server somewhere that is in the cloud, then it would perhaps pull the local storage, which is the SQLite data records, and then send that up to the server via an API. Again, interim data, local storage. So there we go. I'll be doing more explainers over, what things are, and we'll see if we can get down to the root levels, the ground levels. As I've mentioned, I've talked about what a data is, what a database is, the difference between a database and Excel, what a database management system is, what is a relational database, what is SQL, that's what we've covered as well as what is NoSQL. So if you've got any comments or questions or queries, then do let me know. But as I've mentioned, this won't actually get published for a few weeks, because what I'm going to do is pull down the audio, and then we're going to turn this into the next podcast episode. But we've got a few podcast episodes yet to be published, so this will only be available in video format for the members first. And before I do skedaddle and move off, I want to show you, if I can get to it, the How to Code Well site, because this is this thing that has I've been working on. So notice that we have courses. We've got an area now for the podcast. There is still the Discord channel. There is these courses. There's more courses if you click on more courses, for example. And you can purchase these courses. And you might be looking at these courses and going, well, Pete, these used to be free on YouTube. Well, what I'm doing is I'm taking off my courses now off of YouTube. I'm expanding I'm adding documentation to each of the tutorials with code samples, and it's purchasable on howtocodewell.net. So I have something in the region of 16 various different courses on YouTube, and I will be pulling those off. I'll be putting them on another video hosting provider, which you purchase at howtocodewell.net. We've got, at the moment, we've got PHP MySQLi, so that's connecting to a database, as we've been talking about today. Linux Bash for beginners, there's 15 tutorials there about learning how to manipulate the file system and be more comfortable with Bash shell in Linux. We've got PHP command line interface basics, and we've also got PHP strings for beginners. And I do believe there is, yes, here we go. We've got Docker, so Docker for beginners too. So these are both available to purchase on this website, howtocodewell.net, but also what I've been doing is I've been taking off when I say I've been taking off the videos off of YouTube, I've been marking them as members only. So if you want to access these courses and you want to access the code behind them, then do consider joining the YouTube membership if you don't want to join howtocodewell.net. There's basically the two ways to do it. Also, we have the podcast that I'll be adding to, obviously, when the shows go out. So there are 200 episodes here. Anyway, thank you ever so much for watching. Happy coding, everybody. Have a fantastic Saturday.